on your
Live.
camera. Okay.
We are discussing the teleprompters of our dreams. Yeah, I think I have the same one as you, except mine's designed for an iPad. Um,
Right. So this is even smaller. Like this one is
yeah,
only like maybe like I'm trying like just wide enough as a phone, like just big enough to hold a phone.
yeah,
But
yeah.
then I had a remote control. This is when I used to use a script, and I had a remote control, and then I could pause the teleprompter with my hand and then be
Yeah,
able to like read the script. But yeah, I don't
yeah.
use script anymore, so it's not necessary.
I do still use scripts for like Escape Velocity Space News, and yeah, I have the stupid remote that goes with the iPad.
Hmm.
Um, and I hate it. I hate it, hate it, hate
Yeah.
it.
Yeah.
And so I
And so in this case, you're just like you've got a mouse, and your mouse goes onto the little window that is the
exactly.
teleprompter. That's
There's no
smart.
insanity of downloading my Google Docs to text files
Yep.
and like with the teleprompter it wants to go at a set speed or jump a set amount or it attempts to figure out where you are based on the words you've said. And that
Yep.
means I have to go through and delete all my lower thirds and all of my image prompts. So there's a version of the script for the teleprompter and a version for our producer, and it just leaves me annoyed.
Mm.
So Elgato's new thing, I can just use a mouse and scroll past all of that stuff. So there will only need to be one version of the script. It never
Yeah.
needs to come down from Google Docs.
Yep.
And like when I'm narrating, it completely changes the game.
Yep. In
Um,
theory, you haven't
yeah,
you haven't played with it yet, but that's your
no,
plan.
yeah, yeah.
Um, yeah, and so this gadget, I was talking about the Osmo 3. So I have ordered a new I've ordered a new video camera.
Hmm.
I've ordered an FX3, which is it's like a proper Sony video camera as opposed to using a DSLR as my camera. So
I love how I'm
it's
always one step behind you. I finally get my DSLR working, and then you go and order a proper video camera.
yeah. Well, so like right now I'm using a DSLR as my video camera. I'm
Yeah,
using a
same.
Sony A7C, and I love it. Like what I love about it is that it just works. I don't have to think about it, and that is the zone where I am with my gear. Like I think for a lot of people, they want to be able to they want a complicated piece of hardware that they can go in and mess with the settings, and it'll do all these really cool things that it can save in this log format and that. I don't want that. Like what I don't like what I like about my camera is that the autofocus works, right?
Yeah, I have the same thing.
What I don't like about my camera is that it freezes up, or if it overheats and shuts down.
Oh,
And that's just because it's a DSLR. It's not meant to be recording video for an hour long.
okay.
So I need like an actual device that's designed to do that job. So,
Yeah.
but at the same time, I really want the no fuss, no muss version of this. And so that's why I'm going with the proper Sony FX3 camera, which is going to be like it's a real
Yeah.
beginner professional grade video camera.
I
You
just
can-
wanted to not look slightly purple because most webcams see ever so slightly into the infrared, and I just
Yeah.
ended up always looking, no matter what I did with lighting. Like I had an existential crisis futzing with cameras that brought on the switch to the DSLR, where
Yes.
I was like, I have my color card. All the colors on the color card work.
Except for
Shit,
me.
I'm just actually this pale.
Yes. I have the opposite problem, which is that I always get red. I always turn red.
Right.
And
Yeah.
so uh but the DSLR is able to sort of balance it out a little bit. So I'm not quite as red
And
as I yeah.
I am still much paler than you, but I am no longer slightly purple, which was just the
Right.
light from my monitor.
Yeah, and I think it's like whatever's my natural color tone, the camera just couldn't, the smaller,
Yeah,
cheaper cameras just can't handle it. And so
exactly.
now a better camera can do a better job. So yeah, so that's sort of the world that we live in. Um And yeah, so anyway, that's what I've done. I've I've got a new camera that's coming in a couple of days, and I look forward to ignoring almost all of its features. Just that it'll fix my camera shuts off randomly. But no, I think it's great. Like you're using a DSLR right now.
Yeah.
Yeah, it looks a lot better. Yeah. I'm really happy with just the results of using your DSLR as your webcam. It's the way.
And this is such a stupid hack. One of the problems I was running into is it just wasn't white balancing correctly. And I also have a ton of plants in here because basement, it doesn't have a lot of great air circulation. So
Yeah.
I put a ring. The audience can't see this. I can move my camera and they can see it. I have a ring of grow lights around the green screen behind me now.
Mm-hmm.
And that creates enough contrast that the camera's like, I understand. And the plants are happier.
So you know what's my hack for the white balance?
What?
That.
The lights you have on behind you.
Yeah.
Yeah, exact
Yes.
same idea.
So my color changes depending on the color that I put behind me.
That's wild.
Yeah. And so by getting a color that the camera can kind of settle on,
Right.
helps sort of white balance the whole scene. And so the camera averages into a place that I think looks a little better. So anyway, the nitty gritty details of this. But it is so sorry, what camera are you using?
I still have the T7i from back when we bought matching cameras 10,000 years ago.
Oh, well, those are T3i. So you got the T7 now?
Yeah, sorry, I did upgrade from when we got the matching.
Okay.
I thought we both upgraded for some reason.
No,
You switched to Sony.
I switched to Lumix. I got a Panasonic Lumix.
Yeah.
But it had awful autofocus. So like it was unusable. Like I don't care how great your camera is, how sensitive, like if it can't autofocus,
yeah,
and I can't trust the focus, then I can't use it. But the Sonys have always had just rock solid focus. So you can take it to the bank.
I did have the most fabulous moment of stupid while trying to figure all of this out. I like literally had the existential, I'm actually this pale crisis. Ran upstairs, grabbed my Canon camera, did not check to see which lens was on it, and started out with my macro 200 millimeter lens, and no one needs to see their face that up close. No one. So I now have an 18 millimeter lens and the world is happier.
So you're using an 18 millimeter. Yeah.
Yeah.
I'm using, I don't know what it is. I forget. It's a like I can shift the lens. It's a telephoto lens.
Yeah, this one's 18 to 35. It's just on 18.
Yeah, I think mine does that too, 18 to 35.
Yeah.
But really, I just don't touch it. Like it just sits
Right.
there and it acts like my webcam, right?
Yeah.
Like, and chances are that'll be the case. Like when I get the new video camera, I'll swap it in, and then it'll just sit there, and it'll just be my new camera.
Yeah.
But it's really nicer formats. It'll give me more control. It'll, it won't overheat and shut down.
I've been wanting to get a mirrorless body, and this may motivate me to do it because I won't want to remove the camera from my setup.
How would you remove a camera?
No. So I have the T7i in my teleprompter chaos wired in everything.
Right.
And if there's something cool outside, I'm probably not going to want to grab it to go take a photo.
No, I can't use my camera. That's the other thing I want to do. I want to free up my camera to be a camera.
So
because I'm unwilling to disconnect my camera and use it for any other purpose other than for my videos.
And I've been wanting to get a mirrorless body, and this may promote me taking that action.
Yeah. Well, I'm definitely a huge fan of the Sonys at this point.
I really have an investment in lenses I am unwilling to step away from.
I have that same investment. By the way, if anybody needs some old Canon lenses, let me know. I have a lot of Canon lenses, including some very fancy ones. So, all right, let's get on with let's do our job. I know
okay.
At this point, people are losing their mind over this nonsense. So let's get
all right.
down to business.
What episode number are we on?
696.
696. We're going to hit 700 before Christmas.
I'm ready.
Okay. Should we do something special for 750 in 2 years? Okay. We are so enthusiastic about these things.
I don't know. I feel like I just hit so many of these milestones that I just don't even I crossed the 200th episode of my question show. I'm about to cross episode 100 of my Space Bites. I've crossed the 1000th mark of my own podcast. I don't care anymore.
One of our Astronomy Cast people requested that Astronomy Cast go back to doing questions shows, and I was like, Fraser does a really great one. We shouldn't compete with. So can you please promote your questions show during the intro to Astronomy Cast?
Oh, sure.
Sean?
If you want. Yeah.
Okay.
Yeah.
All right. So I'm pressing that record button. I am pressing that record button. It's recording in all the places. We actually look like we belong to the same color scheme for once.
You ready?
It is exciting. Yes.
Here we go. Astronomy Cast, episode 696, mission roll call, part 5, the science at Mars. Welcome to Astronomy Cast, our weekly fast-based.
Fast-based.
Fast-based. Okay, I'm gonna, we'll just keep going. All right. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today, and with me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. As soon as we are done recording this episode, I'm going to start flipping my studio to get ready for this coming Saturday's Hangout-a-thon. And you and I are going to actually be recording our next episode during that event.
I'm excited. And I'm sure you're going to rope me into all kinds of other things as well. I'm ready.
Yeah. Okay.
Now, you got an email. Someone was asking if we would ever do our question show again.
So on Sundays, I do office hours with our patrons. Y'all are welcome to show up. You get the link. And Sean stopped by and he's like, I remember your question shows and they were really awesome. Mm-hmm. Can you do them again? And I was like, no, because Fraser does really good ones that I don't want to compete with. So you need to promote your...
Sure. We kind of do them, though, which is that we record this show live every Monday at 11 p.m. Pacific, 1 p.m., 11 a.m. Pacific, 1 p.m. your time.
Yeah.
And we do the show part, which is like the first half of the hour. And then we stick around and we answer questions for the second half of the hour. Mm-hmm. And so if you're a patron, you get the full audio, don't you?
So patrons get the edited show, no ads.
Then, that's right.
And YouTube has the complete show, no ads.
Right. Yeah, so the complete show is always available on YouTube. And then as you said, I do a question show every week on my channel, and that goes on my podcast. So if you aren't already subscribed to the Universe Today podcast and you want those question shows, they're not with Pamela, they're with me, but they're a good time.
He's learned most of what's in my brain.
Thanks for teaching me. I appreciate that. Another week, another review of space missions in the solar system. Today, we set our sights on the red planet. What are all of the active missions at Mars today? And we will talk about it in a second, but it's time for a break. And we're back. All right. Again, we decided that there was just too many missions. We had to break these up. So today we're going to talk about Mars. And there's a lot going on at Mars.
Yeah, I was really naive when I thought we could review the solar system in 3 episodes.
So adorable.
I admit to my folly. Mars is truly a world occupied by so many robots. Not all of them live. And I'm loving that there is now sci-fi out there where people are taking advantage of the robots, either as like we saw in The Martian, a site where they can grab resources, Or as we saw in one of Alistair Reynolds' series, as something that can come alive and potentially hunt us down later.
I haven't read this one. Which one's this? Is this Pushing Ice?
Oh man, it's his other really long series of books that I totally
Okay.
can't remember the name for.
Right.
I will tweet about it later.
Okay. I've got to. It's not the Revelation Space series, but I will definitely. I'm so into Alistair Reynolds at this
Yeah, his
point.
stuff is
I'm
amazing.
so great. Yeah. What I find amazing with Mars missions is they just last forever.
Yeah,
Like
it
there are Mars missions that are
undead.
all well, they're more than 20 years old at this point, and they're
Yes.
still going strong. And then even the rovers on the surface that were only supposed to last a few months lasted for over a decade. So there's something about Mars like yeah, Mars
Yeah,
eats spacecraft for breakfast, but if you can survive the arrival,
yeah.
then you may very well have a very long and successful future ahead of you.
Mars Odyssey was the first Mars mission I ever wrote a journalism article on. And it it launched in April 2001. I was still a graduate student when it launched. I had just started a job as a journalist when it landed. And it is still functioning.
Yeah.
And they thought ahead in the 90s to make it so that it could work as a communications relay. And it just blows my mind that they had this plan of we need to figure out where we want to go. We need to figure out how to enable rovers to send us more information, which means they should spend their energy getting stuff in large bandwidth to orbit, and then the orbiter sends stuff to us here on Earth. It's just it blows my mind how well everything with Mars has been
Mhm.
planned out, even if we don't know the plans ahead of time as the public.
Right. So with Mars Odyssey, should we just start with? Are we gonna start oldest first? We're gonna start with
Sure.
orbiters, then landers and rovers. All right. Well, let's talk about Mars Odyssey. Like, what is the purpose of Mars Odyssey?
So Mars Odyssey today exists primarily as a relay satellite. It is orbiting round and round as you do, unless you want to crash into the surface of a world. And it's listening for the signals from all of the various landers and rovers that are working at any given moment. So today it's out there listening to Curiosity and Perseverance. And it has worked with the Mars exploration rovers. It has worked with InSight and Pathfinder. It's capturing their signals and sending them back. But I mean, originally its goal was do what every other orbiter does, map the surface of Mars. And it's expected to keep doing it at least until 2025. And I never believe NASA when they give an expiration date for something at Mars.
I mean, there's been a lot of really interesting maps of the surface of Mars
Yeah.
talking about the locations of water ice. And Odyssey has been the spacecraft that helped identify where all of these deposits of water ice are and show us that Mars actually has a lot more water ice closer to the equator than anybody ever thought.
And
Go
this
ahead.
is because it's looking at how high energy particles are interacting with the particles beneath the surface, or in this case, the molecules beneath the surface. And it also has Themis, which is anytime you see thermal images of Mars, it's probably from Themis.
Yeah. And so just again, like you get these like multiple spacecraft collaborating
Yeah.
on science about Mars. But shortly after the Mars Odyssey spacecraft arrived at Mars, you got the European Space Agency's Mars Express.
Also still working.
Still going, yeah. There's a video that we just shared a couple of weeks ago that was this really amazing flyover of the region around Valles Marineris, like not specifically, the big valley on Mars, but the region in between where the Valles Marineris is and the Tharsis Bulge, where all the big volcanoes
Yeah,
are.
yeah.
and it was just like, this is what it would be like to fly low over the surface of Mars, over this region, and you just saw just these amazing valleys and plateaus, and oh man, it was just crazy. And just to think that this is again spacecraft that has been at Mars since 2001.
And it was a collaboration primarily with the European Space Agency as lead, and also with it was a Russian space agency. They have changed names since the beginning of Mars Express's planning through to when it launched. So I'm just going to go with Russia. Yeah, it's one of the missions that reminds you how the current Ukrainian-Russian war has really affected the European Space Agency's exploration of our solar system, because there's this tremendous history of the two agencies working together, and now they're not.
Mm-hmm. Yeah. And so again, same thing, equipped with a suite of cameras, other instruments, and it's just been taking image after image, like orbit after orbit after orbit, and it just keeps taking more and more images at high resolution of the surface of Mars. And it had a partner,
Beagle
which
2.
Well, so I mean, does that count?
It didn't survive landing, but they were like a pair that traveled together, and Beagle was a project of the United Kingdom working solo to try and do their own tiny lander. And tiny versus Mars doesn't necessarily work. I feel like it was kind of a precursor to all of the Google Lunar X Prize missions that we talked about last week that were small and endearing and small teams and just didn't quite make it. It tried. Yeah. It tried.
So then let's talk about the flagship of imaging the surface of Mars, and that's the Mars Reconnaissance Orbiter.
So Mars Reconnaissance Orbiter came in 2005. It was actually after the Mars Exploration Rovers. And so you had the Mars Exploration Rovers landing, and then Mars Reconnaissance Orbiter got there and was able to see them. Mm-hmm. And that moment of, oh, we can see what the rovers are doing from space. That was new and amazing. And in the years since then, and Mars Reconnaissance Orbiter and Lunar Reconnaissance Orbiter are actually twin spacecraft for the most part. And Mars Reconnaissance Orbiter's high-rise camera has been tasked with things like trying to catch spacecraft in the air so we can see their parachutes as they descend through the thin Martian atmosphere.
People always ask me for examples of images. They're like, you see a picture of a satellite and you're like, who took that picture? You're like, well, it's an artist's illustration. Like, this is not a real picture of a satellite.
And then there's MRO.
And then there's the pictures that MRO took. And like the one that is the most mind-boggling is you can see the parachute of Curiosity as it's landing. Like, they timed the landing of Curiosity and then Perseverance when they knew that the Mars Reconnaissance Orbiter was going to be flying directly overhead. And so they could get these images. Mm-hmm. And you legit see the parachute of the spacecraft as it's landing, descending to the surface of Mars. And so that is one of the very few examples of a satellite taking picture of another satellite. It's crazy.
And the resolution of this telescope is the kind of thing where we're just going to keep being able to accomplish new science with it, because there are so many images at such high resolution that you really have to postage stamp them out and expand out just a section of each strip at a time. And my favorite high-rise story is there was a researcher with the mission that just had been working on like mission ops and the kinds of stuff that makes researchers sad, and sent just random images to the printer, picked them up and was flipping through them. And the orbiter had caught a landslide in the process of happening. And because to accomplish color images, it flips through different filters and does a picture in red, a picture in blue, a picture in green, moral equivalent of that was broadly associating. Each color caught the landslide in a slightly different state. And this was the first time we'd seen that the surface of Mars is geologically active in cool ways other than just getting hit by new meteorites.
Yeah. I mean, the resolution on that camera is like it's the most powerful telescope that's ever been sent away from Earth orbit.
Yeah.
I think it does have the same one that's on the Lunar Reconnaissance Orbiter. So, but still, it's a pretty beefy telescope, and it is in orbit around Mars, and it's capable of resolving objects that are down to tens of centimeters across. And so, if there's a monolith hiding on Mars,
we would have found
Reconnaissance
it.
Orbiter would find it.
Unless it was in a permanently shadowed region. I realized that after we said that about monoliths last week. Don't at me. I have since realized it.
Right. All right. We're going to talk about this some more, but it's time for another break. And we're back. All right. So there's one more NASA satellite that is in orbit around Mars we should talk about before we sort of move further, and that's MAVEN.
So MAVEN is perhaps the least sexy in terms of what journalists need to do our job mission. And I use that term because there is a Reddit forum called Earth Porn, which is the most beautiful imagery of our planet ever. And the data coming from high rise, you can just like stare at it and it's glorious. Tracing out the gases in the atmosphere of Mars does not produce the most beautiful data. It produces the most intellectually interesting data, but in general, it's not the kind of stuff that's going to make the cover of National Geographic. What MAVEN is doing is it's trying to confirm some of the readings we've had of the atmosphere from the surface of the world to see what the total, basically, gas column looks like. And it's also looking at the rate at which molecules are leaving Mars' atmosphere. So it's able to sample things, measure things. It's basically a crime lab investigation unit designed for atmospheres. And it's doing really good science. It's helping us start to figure out things like the mystery of the methane. But no pretty pictures for us, unless you like spectra.
Right, but you have the Mars Reconnaissance Orbiter right there.
Exactly.
These pictures. And so to understand, like, when did Mars lose its atmosphere? Is it still losing its atmosphere? What did it look like in the past? What is the composition? And as you said, is there methane being generated somehow on the surface of Mars? These are all really important questions that, if answered, can give us a much better history of just like where Mars came from. Why is Mars a cold, dead world when Earth is warmer, has water on its surface? And, a lot of it comes down to the loss of its atmosphere, its protective blanket, which was keeping it warm. And,
exactly.
And what's that process? All right. So
there are other orbiters.
Yes. So let's move on to other orbiters. Let's move on to ExoMars.
So ExoMars was the mission that carried the trace gas orbiter, which is another don't take pretty pictures, let's measure the atmosphere and what's changing over time mission, as well as the poor Schiaparelli lander that didn't quite make it. It's
like Shades of Beagle too, that it was this European mission with a lander on board, and the lander died, but the orbiter was fine.
Yeah, the lander is a reminder that it takes roughly 7 minutes to successfully get from space to the ground, and it only survived the first 5.
Right.
Because
And,
it
and
didn't take 7 minutes would be the problem.
and so what is ExoMars trying to accomplish?
ExoMars it's an astrobiology program where they're trying to figure out, is this, and again, this is an ESA Roscosmos mission here, and it's trying to figure out, are the things necessary for life, specifically looking at the methane tied to potentially life, what do they look like in the atmosphere? It's also another telecommunications relay. It would have been more effective had the Schiaparelli lander not died 5 minutes into attempting to reach the surface, which it reached too soon. That's a different problem. But it's another one of these ones that's out there looking at the atmosphere and looking at methane. It worked with Curiosity rover to figure out that there's actually a day-night cycle in the release of methane from the surface, which is wild. And it was basically a matter of the one mission was able to do all of its work during the day. The other mission did all of its work at night. And in combination with Trace, they figured out, oh, this is a daytime emission that we're seeing, and I just love that tie-in.
So we've got another couple of orbiters from other countries. So first, let's talk about the Hope mission from the United Arab Emirates, which is really cool.
And it is a mission that nobody ever talks about. Have you come across any science papers from it?
I've interviewed the director.
Go forth, you speak.
Well, I mean, so they've actually got a pretty interesting list of missions. So after the Hope mission, which is their first mission to Mars, an orbiter, they're working on an upcoming asteroid mission. They're going to be following up with that. But, I mean, there's not much to it. I mean, it's like their first attempt at homegrown building a mission to Mars, and then getting it launched. Had it launched on a Japanese rocket, and they were able to arrive and start taking pictures. And the pictures that came back from Hope look quite different from the other spacecraft that are there. And they released a really interesting kind of full planet atlas about a year ago of the entire surface of Mars, and with a lot of the interesting surface features. So, this is not an extremely ambitious mission. I mean, although it is really, it's an ambitious mission.
It's still going.
Exactly. It's looking at, because it's on this very like high orbit. So it sort of flies out to this really high apoapsis and then comes down, close flyby, and then comes back out. And so it's able to take these full images of the entire planet in one shot that we don't see very much. Like, because Mars Reconnaissance Orbiter is like looking through a straw, very close with a giant telescope. And so we don't get a lot of those missions that are able to give that higher perspective.
I now want a really big dust storm to hit, a really big dust storm that leaves Percy and Curiosity alone.
They're fine. They've got nuclear, they've got radioisotopic thermoelectric generators.
They still need to be left alone, because, I mean, I don't need them to get stuck in sand dunes. We know that's a thing.
No, we know that, yeah.
But Hope is a mission that will actually allow us to see the full spin up and evolution of a dust storm. And I mean, normally it's actually amateur astronomers here on Earth that are like, oh, dust storm coming, because they can see the whole planet.
Yeah. We talked about the Discover satellite, which is sitting at the Earth 1 L1 Lagrange point, or Sun L1 Lagrange point, that takes these entire shots of the whole Earth. Yeah. And it's nice to get that sort of farther perspective at the same time that you're then seeing stuff that's up close. So good job to the UAE team.
Yeah.
And then the other one is the Chinese Tianwen orbiter,
and
which
they did something super clever I don't think we've seen before or seen again except from their moon lander. They took a separate camera that they were able to take full-on pictures of their rover with the separate camera, so their selfies don't require them to like edit their own rover arm out of the selfie. I guess it's not really a selfie, it's a friend taking a picture for you. Sorry, that was just something super clever that I am overly excited about. They've also been exploring the same region of Mars where we know there are active quakes. And so there's the potential as more and more data comes in that we're going to be able to understand why is this extreme area of Mars so active. We just don't know, and we want to know.
All right, we're going to talk about this some more. Now we're going to move to the ground missions, but it's time for another break.
Okay.
And we're back. All right, let's go to the ground.
So I'd already hopped there with Tianwen 1.
So go with Tianwen, and then we'll continue on there. I mean, they've got the Zhurong rover is theoretically operational, so it like just barely makes the cut because it hasn't been officially declared dead, but it has gotten clogged with sand on its solar panels in the same way that
Opportunity did.
That Opportunity did, and Insight.
Yeah.
And they haven't heard back from it, and probably it's done for. So does it count for our operational missions at Mars? I mean, if
it's still listed as operational.
Yeah, it's not doing great.
I know it's not doing great.
Yeah,
but I'm willing to give it time.
Sure, if you want.
All right. So it's in the Utopia Planitia region of Mars. It has its own orbiter, Tianwen 1, and please correct my pronunciations. I am so grateful you.
Tianwen.
Yeah. And it was exploring vigorously with a little camera that could see it, which I found overly exciting. And this entire mission, I saw lots and lots of people going, well, it's not as, and then comparing it to Percy and Curiosity, which is really unfair. This is their Pathfinder. This is their Sojourner. This is their first attempt. And iterative design says you don't start by doing the most complex thing. And they succeeded on their first try.
Yeah.
That's insane.
Yeah. Yeah, and it's been doing a lot of they chose an interesting landing site, one that nobody had ever been to before, and they have been finding some really and one of the things that the Chinese do with their vehicles is they give them a ground penetrating radar. So they had one of these on all of their lunar missions. They were able to measure the depth of the regolith on the moon, and they had a similar version of this on the Mars rover, and so they were able to measure the depth of regolith under and searching. Now they weren't able to, one of the things they were hoping to find was deposits of liquid water or even water ice underneath the rover, and to the depth that they were able to reach, they weren't able to find any of that water. But still, like an amazing accomplishment, a instrument that had never been on the surface of Mars before. And so every part of that I think has been great, and it's too bad that they lost it. And I guess that's what happens to solar panels on Mars. It is an unsolved problem in Mars exploration. Well, and I know you're like, why don't they just? Like in your mind, you're thinking, why don't they just?
Because there's not enough plutonium to do
No. Like, why don't they try to brush off the solar panels? Why don't they try to,
no. Insight is the only mission that has tried to clean its own solar panels.
Yeah, by dropping sand on top of the solar panels.
I love that.
Yeah. And so the thing that I always say is like in the spring when pollen falls on your car, and you get this sort of yellow film across everything on your car.
And there's no no easily removing it.
There's
It
no,
just
you can't remove it without water. You got to
smears.
scrub it, right?
Yeah.
And so that's what that dust on Mars is like.
Yeah.
And you just can't brush it away. You can't blow it away. You can't tilt the thing and shake it off. Stuff just gets in there and hangs on tight and forms this film that is really hard to remove. All right, we got like 2 spacecraft and a buddy left.
All right.
First, and then we'll talk about Perseverance.
All right, so Curiosity is over in Gale Crater, slowly but surely climbing Mount Sharp. And what's cool is as it climbs, it is hitting different geologic eras on Mars when water had hit different heights on Mars. And so it's documenting all sorts of super cool features, but it is showing its age because it takes forever to get from point A to point B because it doesn't have the same self-driving AI that we have over on Percy. It's gotten better. They've installed software updates, but essentially it sends back all of its images. The researchers work all Mars night coming up with plans for the next day based on those images, and the rover will drive a little bit, stop, image, figure out, okay, rove a little bit, stop, image, figure out, go a little bit. And
Where should I go now? What do I do about this rock? That looks scary. What should I do?
Yeah, and they recently had to take a fairly significant detour because they hit a fairly dangerous part of the climb. But it's doing good. It's reached past all of its mission objectives, and it is able, I think it has one wheel currently lifted up because it wasn't doing so well.
No, I mean, I think you're mistaking it for
that
Spirit.
was Spirit. Okay, I
yeah.
combined
I mean, its
rovers.
wheels are wearing down.
Yeah,
but they're still fine. But they're definitely, there's holes and chunks and stuff in the wheels on Curiosity at this point for sure.
but yeah, we're regularly getting new images from where it is on Mount Sharp. It is literally seeing stream beds cut through the landscape as water pooled and escaped and flowed downhill.
Yeah.
And it's like climbing the side of the Grand Canyon in a way where you can see different points in the Colorado River going through the Grand Canyon. It can see different points in the lake level in Gale Crater, and it's just cool and shows how alive Mars really was.
I mean, I think that like there has been a constant stream of news coming from Curiosity, and there's we've done whole episodes on Curiosity, and there's no way we could encapsulate it, but it is still going strong, still doing science. Tons of new papers are being written about it. It's a really exciting mission still, as exciting today as it was when it first landed 11 years ago. So old.
And it's getting high enough to get really good landscape shots.
Yeah, totally. All right, we'll talk about its not twin exactly, sibling.
It's
Perseverance. It's younger sibling.
It's much younger, later generation. I'm going to go with like second cousin.
Sure.
Percy is a part of what we hope will be a 2-part mission where it's going around, it's collecting samples in, I just forgot the name of the crater it's in. Jezero. It's collecting samples, and Jezero Crater has a river delta where essentially water burst through a wall and then just spread debris. So as it goes through, all of this debris that was carried to the delta represents a variety of different landscapes on Mars, all in one place. And so as it goes, when it encounters cool things, cool rocks, cool soil, it's able to collect samples, hold on to the samples like eggs, and then it's depositing them in different caches that hopefully future missions will be able to retrieve and bring back. It's getting
those are the backups. I was going
to get to that.
Yes,
it's
the main
taking 2
samples
of each.
Yeah, so the main samples, right, it's taking multiple copies of different places. It's holding one set of them internally in this special sample container,
Yeah.
and then it's pooping out samples out onto the surface that then, in theory, if there's a problem with the main group, then a collection rover or helicopter could fly along the route, pick up the samples, and bring them back to
I
the
like
sample
my
return
egg
mission.
laying analogy better.
Sure. Yeah, sure. Egg laying. That sounds good. And as you said, right, like artificial intelligence, machine learning
It's
plays
awesome.
a big role in allowing it to cover a lot of distance compared to previous missions. It chose its landing site.
It can process its path as it goes.
Yep.
It's not going as fast as a Tesla, but it is using what has been learned through all of the self-driving car research to figure out how to navigate a landscape much more complex than what we ask Teslas to do.
Right.
And
But without cyclists riding around, like
yeah,
nothing
yeah,
is moving quickly
we
through its
hope.
field of view. And of course, the most amazing addition to this mission was a helicopter.
Yeah. So after Curiosity's success, NASA engineers were given permission to stash a helicopter, Ingenuity, and it's not a quadcopter, it's an actual helicopter, in the belly of Percy. And Ingenuity is nicknamed Jenny, so it's Jenny and Percy. And one of the things that you run into with rovers is there's a lot of landscapes that you just can't navigate through because there's either risk of getting stuck in sand dunes or there's cliffs. That's a thing. But Jenny is able to go out and fly over these landscapes and send back data. So we're able to essentially scout ahead, go to the places the rover can't go, and get all this data that otherwise wouldn't be possible. And this is an exciting new way of exploring that the Dragonfly mission is really an inspiration for. Dragonfly is going to be going to Titan and flitting from location to location. And I look forward to a future where we can essentially learn from both Tianwen and Percy and always have that second thing that can take photos of your rover after landing to do a "are you healthy" and let's just
Yeah.
be cool and send back selfies. And then that flying sidekick that can scout around for you. It's just
I
awesome.
can't imagine a future mission to Mars not bringing a helicopter with it.
Yeah, yeah.
Like, it seems incomprehensible based
It will
on the amount of
happen,
value. It
but
has to like, they will all be equipped with helicopters because just having this aerial
yeah. Weighs
scout
next
that
to
can fly
nothing.
around that weighs next to nothing, is constantly flying around, searching the landscape, identifying interesting features to go and check out. It's just is so much value for so little weight and cost. It seems like just the way to go.
Yeah.
You can imagine future Mars, like human Mars explorers, bringing these helicopters with them, setting them up, deploying them, having them scout the terrain around them, and just helping them understand where they are and what they're looking for and interesting geological features that they should go and check out. Yeah, it's game changer.
Yeah.
Like I think one of the most exciting developments in space exploration was the addition of this helicopter to this mission. I mean, the mission's been great, but that there was a helicopter flying on Mars, just like every time I think about this, it blows my mind.
And it's off the shelf for the most part. They use a golf rangefinder. They use a cell phone camera.
Yep.
And they've been able to
Astonishing.
debug it. It's awesome.
Yep. All right. That wraps up our investigation of all of the missions at Mars. Thank you, Pamela.
Thank you. And next week, we are going to go to the asteroid belt or Jupiter. What have we decided?
Well, I think we're just going to do everything beyond at this point.
Okay, that is
It's just like Juno, the interstellar spacecraft,
Psyche, Osiris Rex, Apex.
Lisa. No, sorry.
We'll figure this out next
Yeah.
week.
Yeah, I think
So-
that'll fit within one episode.
And if you are watching this before the weekend of November 3rd, 4th, and 5th, we will be recording our next episode over the weekend. I will be sending messages out to our patrons. And I would specifically like to thank all of you who have joined at the Pamela will attempt to pronounce your name level and higher. This week, I would specifically like to thank Nate Detweiler, Philip Walker, Sean Matz, Frank Tippin, Lou Zealand, Benjamin Kerrer, Bart Flaherty, Nyla, the Lonely Sand Person, John Drake, Brian Kilby, Jordan Turner, Arthur Latz Hall, Paul Esposito, Robert Hundle, Bob Zatsky, Daniel Loosely, Sydney Walker, David Bogarty, Sabre Lark, Hal McKinney, Reuben McCarthy, Daniel Donaldson, Christian Golding, Ron Thorson, Frank Stewart, Time Lord Iro, Jason Kadarkis, I don't know, Will Hamilton, Jeff McDonald, and Lee Harborn. Thank you all so very much. You let us do this show and pay all the people behind the scenes to just keep things going.
Thanks, everyone, and we will see you next week.
Bye-bye. And then they saved.
That was a beefy one.
It was, but it was worth every second.
All right. And I still, in my mind, I was like, time. Like, come on, Pamela, go, go, go. Come on, move it on, move it on,
Sorry,
move it on. Come on.
Sorry.
No, it's not your fault. There's just a lot. There was a lot. But I know that my job is to keep the machine rolling. So
I love that people have started calling Perseverance and Opportunity Percy and Jenny, following Opportunity being Opie. I'm easily amused. Why are you giving your system such a terrible look?
Giving my system terrible luck?
Looks.
Oh, I'm just trying to make sure this goes through my
okay.
Dropbox. Yeah, I'm just concentrating on the technical parts of doing this show.
Okay.
All right. I'm uploaded. Everything is safe. Arjun asks, can they tell the difference between water being a permanent feature and a one-time colossal water event? Oh, interesting question.
So water being a permanent feature would imply it's still there. So I think what you mean is
no, like
water that lingered over thousands of years.
Yeah. As opposed to a flood.
So a flood will cut through the landscape in different ways than a slowly meandering body of water. Yeah. So there's some really neat research that's being done here on Earth that looks at dry riverbeds and is able to start making predictions of what was the flow rate and how long did it run to create what we're seeing. And that research can also be applied to Mars, to Titan. And it's basically how was the landscape cut up. You also can look at what kinds of minerals had time to form, in what amounts. And then there's things like we have basically when high energy particles from the sun interact with water ice beneath the surface, it releases neutrons we can detect. And this is giving us a sense that there are probably frozen glaciers covered in dust on Mars, which is just cool. So yeah.
Yeah. Zafan asks, when will we get a satellite in an aerostationary orbit? Do you know an aerostationary orbit?
Yeah, so like geosynchronous, except for Aries, which is Mars. Like geo is Earth.
Oh, I see.
I don't know what altitude that orbit would be because it's such a tiny world.
Yeah.
But the problem with that is you're
like
only seeing one place on Mars, and that would be disappointing.
Oh, here we go. So it's only 13,634 kilometers. So an orbital radius of 20,000 kilometers, or about 3,000 kilometers inside the orbit of Deimos.
Okay. So that's a perfectly reasonable
Mhm.
altitude. But I mean, again, it would be boring. It
Yeah,
makes
what do you need it for?
sense once we start um, saying, this is the location humans shall go. Um,
Yeah.
because then we'll want to be able to do weather and communications around the clock. But until then, until we start actually selecting a site and preparing for it, there's no real reason to focus on a part of the surface.
Yep. Um, Arjun asks, how many countries are at Mars in some capacity, satellites, landers, etc. So unfortunately, we had to not mention the Mom mission from India because it had recently
Yeah, it no
wrapped
longer
up.
is functioning.
So what have we got? We've got the US,
So that
we've
have
got
made it in total
are are there
successfully.
right are active right there, US,
China,
UAE, China, India, Russia,
ESA.
and Europe, ESA.
Yeah.
So
Eh,
7
yeah.
have sort of pulled this off. Yeah. Like I don't think Japan's working on their mission to the moons.
They went boink their first attempt, and
Yeah.
Mars eats things. It's kind of its
Hmm.
thing, and that's why we really need to celebrate that China pulled it off their first try. Um, yeah.
Helmikitty asks, I'm very curious if starlight is less redshifted observed from Mars as compared with Earth based observations, which might
No,
imply outbound material streaming from our sun causes redshift.
it's the same.
Like the
If you
gravitational
color,
well that you're in at Mars is slightly less than the gravitational well that you're in at Earth. And so there would be, from your, if you're on the ground, a slight different perspective in the redshift, right?
right, but it's not the kind of thing that is uh, within. So there's two different things. What he's worried about is the redshift due to location in the sun's gravity well. And
Mm,
so the orbiters are going to see the same colors of the stars, and the landers are going to see the same colors of the stars within the band pass of the
right.
filters we use. And there's been cool images taken of like looking back at the planet Earth and things like that.
Arjun asks, if a Mars satellite dies, is it parked in a higher orbit?
Um,
No.
no, that isn't something that we have fueled the missions for because it hasn't been a concern that we're going to fill in orbit. Um, yeah.
Yeah. Any questions over there on Twitch?
No, I'm just seeing general enthusiasm and a poor beagle.
Yeah, they found. I forgot to. We didn't mention it, but Mars Reconnaissance Orbiter did find Beagle, and
Yeah, yeah.
and
And
that sucked.
and there's joking about sandworms, which brings me joy.
Worm sign. All right. Well, we've reached the end of our hour,
We
so it's
have.
time to wrap things up. So thank you everybody for joining us today. Thank you, Pamela, for bringing the brain. Thanks to all the moderators for staying on top of the comments, which got a little weird today.
Oh,
I've been
really?
watching. Yeah, yeah, yeah.
Twitch was normal.
Yeah, no, the YouTube comments got a little weird today.
All
But
right.
the moderators were all over it and everything is fine. I've got my question show tonight at 5 o'clock. So if you want to come join, hang out, that'd be fun. Otherwise, we will see all of you next week. Thanks, everyone.